Right now, if you open a developer terminal in Shanghai, the AI software on your screen is quietly lying to you. To your eyes, it looks like a standard date, but to a server in Silicon Valley, it's a hidden tracking beacon. In late June 2026, Anthropic quietly turned their public developer tool into a corporate counter-espionage trap. By secretly weaponizing invisible Unicode characters, they found a way to bypass network security, hunt down foreign tech operations, and catch trade secret thieves red-handed. This isn't just a software update. It is the first undocumented strike in a multi-billion-dollar corporate spy war, and the code running on your machine just became the battlefield. The most fiercely contested border in the modern world does not exist on a map. It isn't guarded by concrete or infantry. Instead, it is drawn inside the invisible architecture of software code. For the past 2 years, a quiet, asymmetric war has been raging between the frontier AI labs of Silicon Valley and the rapid response engineering teams of East Asia. The prize is total cognitive dominance. The rules of engagement have been simple. American labs build massive, closed-source models costing hundreds of millions of dollars. Foreign labs use clever engineering to extract that intelligence through the public API for a fraction of the cost. But in late June 2026, the gatekeepers stopped playing defense. When Anthropic quietly pushed version 1.9.1 of its developer tool, Claude Code, they didn't just update a command line interface. They deployed a digital trap, an invisible watermarking system designed to catch foreign tech operations red-handed. And the way they did it reveals a chilling truth about the future of intellectual property. When data can be copied instantly, the truth itself becomes a weapon. It was uncovered by open-source developers and researchers from Ant Group, who noticed something bizarre happening inside the hidden system prompts of Claude Code. When a developer runs a local AI assistant, the software automatically bundles their code with a hidden block of instructions before sending it to the cloud. This instruction block includes basic context, like the current date. But researchers realized that if a user ran this tool through a third-party proxy, or if their system time zone was set to Asia Shanghai or Asia Urumqi, the software subtly mutated the text. If you were in New York, the system prompt read normally. Today is 2026-06-30. But if the system detected a Chinese network signature or keywords like DeepSeek, the text transformed. The hyphen became a forward slash. Or even more brilliant, a standard apostrophe was swapped with a Unicode character, specifically U plus 02B9, which looks identical to the human eye, but reads as an entirely different string of data to a computer. The metaphor. Think of this like classic 20th century mapmaking. To protect their work from being plagiarized, cartographers would invent entirely fake trap streets or microscopic spelling errors on their maps. If a competitor copied the map, they would unknowingly copy the fake street, proving the theft in a court of law. Anthropic did exactly this, but with natural language. They injected digital dye into the prompt. To understand why Anthropic resorted to such extreme, covert tactics, we have to look at the cold economic reality of model distillation. Training a flagship model like Fable 5 or GPT-5 requires an astronomical layout of capital. You need thousands of proprietary chips running for months, burning millions of dollars in electricity just to map the statistical relationships of human language. But once that model is live, a competitor doesn't need to replicate that process. They can simply run millions of automated questions through the public API, capture the premium model's highly refined answers, and use that curated data to train their own cheaper open-source models. This is model distillation. It is the ultimate shortcut in the AI industry. It allows a competitor to inherit hundreds of millions of dollars of research for the price of a standard API bill. Traditionally, tech companies protect their servers using standard network telemetry. They track IP addresses, analyze browser cookies, and block suspicious traffic headers. But the engineers bypassing these blocks are highly sophisticated. They route their requests through complex networks of intermediate proxy servers that scrub away all network metadata. When the request hits Anthropic servers, it looks completely clean. This brings us to the core structural incentive. Anthropic realized that while a proxy can strip away network headers, it cannot alter the actual natural language text inside the prompt without breaking the code execution. By embedding the tracking beacon into the text itself, Anthropic created a security measure that bypasses every network defense on Earth. The moment that distilled data is fed into a competing model, the mutated Unicode characters are logged, giving Anthropic definitive proof of exactly which accounts and proxy networks are leaking their intellectual property. When this leak broke, the viral tech ecosystem reacted with predictable panic. The dominant narrative across developer forums was one of outrage. Activists claimed Anthropic was violating developer privacy, running covert client-side surveillance, and operating with a hypocritical lack of transparency for a company built on the premise of AI safety. But if we look past the sensationalism, that interpretation fundamentally misunderstands the physics of digital assets. Anthropic was not reading private developer code through this mechanism. They were validating the integrity of their own outbound text pipeline. The engineering team later confirmed this was a targeted temporary anti-abuse experiment aimed strictly at unauthorized resellers and industrial-scale distillation pipelines. The real story here isn't a corporate privacy scandal. It is a structural demonstration of how desperate the defensive position of closed-source AI companies has truly become. The fact that a premier AI lab had to resort to hiding invisible characters and text prompts proves that traditional software security is entirely obsolete in the era of artificial intelligence. If your core product is weightless, intangible weight matrices that can be reverse engineered through a standard chat window, you possess a product that is fundamentally impossible to lock down by traditional means. The invisible watermark wasn't an act of corporate malice, it was an act of economic desperation. Shortly after the discovery, Claude Code engineers merged a pull request to roll back the mechanism, stating that stronger alternative mitigations were now online. The invisible trap was sprung, exposed, and dismantled in a matter of weeks. But the precedent has been set. We have entered an era where corporate labs will willingly alter the microscopic output of their own software to protect their market cap. It forces us to confront a deeply unsettling shift in how we interact with digital tools. If the software we rely on is secretly modifying the text we see based on our geographic location, our time zone, or our political jurisdiction, just to fight a corporate trade war, then the integrity of our digital landscape is fundamentally compromised. It leaves us with a profound dilemma as we look toward the next generation of frontier models. If protecting multi-billion-dollar artificial intelligence requires the quiet manipulation of language and the corruption of basic data transparency, can we ever truly trust the gatekeepers who control these models? Or is a system that requires invisible deception to protect its value inherently broken from the start? Let me know your thoughts in the comments below. Let's hash it out.